Okay, so we're starting a new chapter now, algebra students. We're in chapter 7. We're going to combine two things today, so I'm going to move a little quick because they aren't complicated. I think it's nice to put them all together. We're going to put 7.1 and 7.2 together, adding and subtracting polynomials and then multiplying polynomials. Those are the two things. There's going to be two different pages of homework, okay, but combined into one concept. So I'm starting here on page 259. I'm skipping some other definitions I'm not worried about for you right now. A polynomial is a monomial or a sum of monomials. Each monomial is called a term of the polynomial. Who cares? That's a bunch of information I don't want you to be worried about. The gist of this is, if you see in the red here, this is called a trinomial because you have three terms. X squared, 5x, and 2. And again, I'd have this pulled up on your page, either in Big Ideas or on the copy that I put into your Schoology so you can be following along with me. In blue is a binomial because there's only two terms, 5x and 2. Okay? It's important when you want to write these in what's called standard form, okay, that you write them in order from the greatest exponent down to the smallest or no exponent. So at the bottom here, you see they write this 2x cubed plus x squared minus 5x plus 12. This is written in standard form because it goes from the greatest exponent of 3 down to 12, which is the constant with no exponent. X cubed, x squared, and x, that's how you write them in standard form. So if you come across one of these problems and they're jumbled, you need to rewrite them first. And that's going to show in this next example. Let me move it up. So in this example, it says, write 15x minus x cubed plus 3 in standard form. Identify the degree. I don't care about the degree and leading coefficient. That's not my concern. Okay? So when we look at this, we've got 15x, x cubed, and 3. We run it right in standard form. So your first term is your largest exponent, which is the negative x cubed. Do not forget the negative sign. Your second greatest is just x. Notice there's no x squared here, but there's an x. It's a positive. And then your last term is the constant of 3. So we've rewritten 15x minus x cubed plus 3 to look like negative x cubed plus 15x plus 3. It's now written in standard form. Not a challenging concept at all. This next thing, classifying polynomials. No. I just want to introduce what a polynomial looks like now to get into the actual math involved here. So the first one is called adding polynomials. Is that big enough?
Yeah, that's good.
There we go. So letter A, 2x cubed minus 5x squared plus x plus 2x squared plus x cubed minus 1. Okay? Now, first thing you should notice is this second term is not written in standard form. So before you go to add these together in what's called the vertical format, put it into a form that's standard. So you get everything written correctly. Okay? That's just rewriting it in standard form. I put the x cubed where it belongs. They've done it here for you. I'm not going to rewrite what's already written. 2x cubed minus 5x squared plus x. We're adding plus x cubed plus 2x squared. Notice there's a blank here because in the second term there's no x. And there's a blank here because in the first term there's no constant. So everything just lined up correctly. And you just add them together. 2x cubed plus x cubed is 3x cubed. Negative 5x squared plus 2x squared. Negative 5 plus 2 is negative 3x squared. Plus x with nothing is just plus x. And minus 1 with nothing is just minus 1. So you've now added those together in what's called vertical format. In horizontal format, that's more typically what we do when we see this, is I say to you, we need to combine like terms. That's all we do is we combine like terms. So I have a 2x cubed here. I have an x cubed here. I combine those like terms. They're both positive. That's 3x cubed. I have a negative 5x squared and a positive 2x squared. I combine those, negative 3x squared. I've got a positive x with nothing else, and a negative 1 with nothing else. So to me, the horizontal format, or what I like to call combining like terms, is probably the easier way to go here, okay? So I'm gonna just use that format only for B. If you want to use vertical, that's fine, but that's not what I'm gonna do. Combine like terms, I have a 3x squared and an x squared. That combines to give me 4x squared. I have a positive x and a positive 4x. That becomes a positive 5x. Then I've got a negative 6 and a positive 10. Negative 6 plus 10 is positive 4. So I've just combined like terms, no big deal. That's adding polynomials, the easiest thing to do. Adding polynomials. Hold on, that's right. Okay? The next hardest thing, which isn't that hard, is subtracting polynomials. Okay, and it looks like these. I'm not even going to bother with the vertical format. I think the vertical format, I don't want to say it's dumb, I just don't think it's practical. Let's put it that way. I don't see that as being practical. I don't think you'll ever really use this. We're just going to do combining like terms. What makes subtraction slightly harder, of course, is you're dealing with negatives. You're subtracting this entire term. So what that means is you're adding the opposite signs. I have 4n squared plus 5 here, minus, in brackets, negative 2n squared plus 2n minus 4. Because I'm subtracting this whole term, I change all the signs and add it. So I'm going to rewrite it. 4n squared plus 5 plus, change the sign, 2n squared, change the sign, minus 2n, change the sign, plus 4. Okay, so this doesn't change on the left side of the subtraction sign, but on the right side you change the subtraction to a plus, and then you change the signs of everything inside the parentheses. Negative 2n becomes positive 2n squared, plus 2n becomes negative 2n, minus 4 becomes plus 4. And now I just combine like terms. I've got 4n squared and 2n squared, that becomes 6n squared. I've got negative 2n by itself, no other n's. And then I've got a plus 5 and a plus 4, which is plus 9. Okay, and here's should be your final answer. And if you look down here, the way they did it, same thing, 6n squared minus 2n plus 9. Subtracting polynomials. Okay? We'll redo it. We'll do one more example. 4x squared minus 3x plus 5. And then it's plus the opposite sign. Negative 3x squared plus x plus 8. Okay? So I have 4x squared minus 3x squared, leaves me with x squared. Negative 3x plus x leaves me with negative 2x. Plus 5 plus 8 is plus 13. Okay? So that's what that becomes when you subtract polynomials. I'm betting we have some examples here. Maybe on the next page. We do. Always good. Find the sum or the difference. Erase this out of the way. All right, so what I'm going to ask you to do, not you, Megan, you aren't stopping, but you guys, when you're going through this is a time I want you to stop, have a piece of scratch paper, and work through these problems. When you're done, resume play, and we'll go through them together. So go ahead and pause at this time.
Pause.
All right, so now we're back. So the first one is addition. No big deal, combine like terms. We have a b and a positive 4b, that's a 5b. A negative 10 and a negative 3 is a negative 13. 5b minus 13. Number 9 is another addition. So I combine like terms, don't have to worry about changing signs or anything. I have an x squared, I have a 7x squared, that's an 8x squared. I have a negative x and a negative x, that's a negative 2x. And I have a negative 2 with no constant here, so that just becomes a negative 2. Okay? The next ones are subtraction. So again, we're changing the sign to addition and changing all the signs inside. I'll rewrite it. P squared plus p plus 3 plus 4p squared plus p minus 3. Please don't forget to change your signs. Some of you are going to forget that. You're going to miss those. Combine like terms. P squared. 4p squared is 5p squared. P and p is a 2p, or not to p? That is the question. I already did, so I'm good. Thanks for asking. All right, and then we have a plus 3 and a minus 3. Obviously, those negate, become 0. You don't write that. This is your final answer. All right. And lastly, negative k plus 5 plus negative 3k squared plus 6. Some of you may write it this way. It's how I would write it. I would write this as a minus 3k squared. Either way is fine, as long as you change this sign as well. Combine like terms, minus 3k squared is the only k squared we have, so that's your first term to write it correctly in standard form. Minus k is the only k we have. And then we have plus 5 and plus 6 is plus 11. Okay, there's your examples. All right, it gives you kind of an interesting real-life problem I want to work through briefly. We have this tall building. A penny, it says it's thrown. I think what they meant is just dropped. So here's this lady trying to hit somebody in the head with a penny down below here, right? She drops a penny from a height of 200 feet. That's a tall building. That's a 20-story building. At the same time, a paintbrush is dropped from a height of 100 feet. A couple of littering idiots. All right, the polynomials represent the heights of the object after t seconds. So the penny drops at this rate. Negative 16t squared minus 40t plus 200. And the paintbrush drops at this rate, negative 16t squared plus 100. Okay, so what the first question's asked, write a polynomial that represents the distance between the penny and the paintbrush after t seconds. Okay? Write a polynomial that represents the difference. What does the word difference mean? Thinking. Difference means subtraction. You're aware of that. So I have negative 16t squared minus 40t plus 200 minus negative 16t squared plus 100. Okay? Rewrite negative 16t squared minus 40t plus 200 plus 16t squared minus 100. And combine like terms. I have negative 16t squared, positive 16t squared. They cancel each other out. I have negative 40t is the only t I have, plus 200 minus 100. Okay? So this is the polynomial that represents the distance between these two pennies after t seconds. Now, the second part of this question says, interpret that data, which I like. That's what you're trying to figure out, is what does this actually mean? So what that means is this: at 0 seconds, when t is 0, when they first drop, both objects, what is the distance between the two? Well, if t is 0, 0 times negative 40 is 0. The difference is 100 feet, which we already knew that. The penny was dropped at 200, and the paintbrush was dropped at 100, so at the start, they were 100 feet apart. But what this then means is that for every second that goes by, the distance between them expands. I'm sorry, this is plus 200. There we go, or plus 100. The difference, the distance actually shrinks. So after 1 second of being dropped, the distance between these two is negative 40 times 1 plus 100, which is negative 40 plus 100 equals 60. After 1 second, they're now only 60 feet apart. What does that mean? That means the penny is falling faster than the paintbrush. It's catching up to the paintbrush. How does that make sense? You would think the paintbrush would fall faster because it's typically heavier than a penny. Why would the penny be falling faster? This is more of a science question than a math question. Any guesses on that answer? It's because of wind resistance, air resistance. You can ask Geigel about this or Ms. Vieira. A paintbrush has a wider surface area, so as it drops and falls, more air is pushing up against it, making it fall slower than a penny whose surface area is very small, especially when it's turned sideways, so it catches up to the paintbrush much faster. So that's the practical application of this problem. All right? All right, let me cough out my coronavirus a second. All right, moving on.
Oh.
So that's that. And there'll be exercises I'll be assigning here for adding and subtracting polynomials, but we're combining that with multiplying. So that's what I want to get into next. All right, so multiplying polynomials. There are 3 different ways they show you how to do this. I'm going to tell you, I am throwing out the first way. Distributive property, you're never going to utilize that. It's complex and dumb. You'll never use it. You're welcome to look at it yourself if you like. I don't like it at all. I'm going to go to example 2. Multiplying binomials using a table. Now, I'm going to tell you, this whole business of using a table is new to me. We didn't have this when I was a kid. We just learned method 3, which we're going to go over. But this is called the box or the table method. And some people really like this, and which is fine. If that's the way you want to do it, I don't care. I like FOIL, but that's because that's what I got used to. The box method isn't tough. So you've got this polynomial, or this binomial up here. Find 2x minus 3 times x plus 5. Okay? So write each binomial as a sum of its terms. Blah, 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 blah. I don't like step 1 is confusing. Look at make a table of the products, right? So at the top they wrote 2x and minus 3. On the side they wrote x and positive 5. And then you just multiply across each square. Kind of like your, what are those tables called in biology you guys are doing?
The Punnett square?
The Punnett squares, like the Punnett squares, thank you. Okay, so x times 2x is 2x squared. X times negative 3 is negative 3x. 5 times 2x is 10x. And 5 times negative 3 is negative 15. Okay? And then you combine any like terms and rewrite. There's only one 2x squared. I have a positive 10x and a negative 3x, which makes that a positive 7x. And I just have one constant, negative 15. So using the table gives me this polynomial. All right, so down below, we're skipping 1 and 2 because that's the distributive property. I don't want to worry about the distributive property. You're going to do 3 and 4 using the table, and then we'll go over it together. So go ahead and pause at this moment. You do your pause, maybe.
Hold on. Pause.
There you go. All right, and we're back. So, number 3, we have p plus 3 times p minus 8. So let's make our table. And 3 lines. 1, 2, 3. Da 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 da. There you go. Okay. So I put p plus 3. P and 3 and p and negative 8. okay, because this is p plus 3, this is p minus 8. And we do our Punnett square. P times p is p squared. P times 3 is 3p. Negative 8 times p is negative 8p. Negative 8 times 3 is negative 24. Combine our like terms and rewrite, we get p squared minus 5p minus 24.
Was that number 3 you just did?
That's number 3. Okay? Let me see if I can erase this without messing up. My Punnett square, that's good for you all taking biology. This should be pretty easy for you. All right, number 4 is r minus 5 and 2r minus 1. Okay? 2r times r is 2r squared. 2r times negative 5 is negative 10r. Negative 1 times r is negative r. Negative 1 times negative 5 is 5. Combine like terms, rewrite 2r squared minus 11r plus 5. And you're done. Okay, that's how you use a table. And I kind of like that method, it's not bad. The third one that I like is FOIL. Right? The FOIL method. First, outer, inner, and last. Okay? First, outer, inner, and last. FOIL. First terms, outer terms, inner terms, and last terms. So we have this binomial being multiplied. X plus 1 times x plus 2. Okay? So, first terms, the first term in each brackets is an x and an x. That gives me x squared. The outer terms, the ones on the outside of each, is an x and a positive 2. That gives me 2x. The inner terms, the inside ones, the 1 and the x. 1 times x is x. And then the last terms, the 2 that are at the end, positive 1 times positive 2 is a 2. Combined like terms, I have x squared plus 3x plus 2. Okay, that's FOIL. So let's just see, let's just go right down the examples, just do what we've already done, so we might as well just go and do our own examples to work through it. 5 through 8. This will be the last thing that you guys will do for this section. This is why I was combining the two sections, because you should not find them to be terribly challenging. So, go ahead and pause here, work them out on a piece of paper, come back, we'll go over them together. All right. So, FOIL number 5. First, m times m is m squared. Outer, m times negative 7 is negative 7m. Inner, negative 3 times m is negative 3m. And last, negative 3 times negative 7 is positive 21. We combine our terms, m squared minus 10m plus 21. Okay? Number 2, they want to just mess with your mind a little bit and throw fractions in there. Well, that's not the next one, is it? Number 6, sorry, over here. 6, first, x times x, x squared. Outer, x times positive 2 is a plus 2x. Inner, negative 4 times x is negative 4x. And last, negative 4 times positive 2 is negative 8. Combine our like terms, x squared minus 2x minus 8. Okay, number 7. First, 2u times u is 2u squared. Outer, 2u times negative 3 halves is negative 3u. Inner, 1/2 times u is u over 2. Oops, not 4. Why I wrote that, I don't know. u over 2. And then Last is positive 1/2 times negative 3/2 is negative 3/4. It's ugly, doesn't matter. Combine your like terms. I have 2u squared minus, we'll call this 5/2 u minus 3/4. Okay, this is just a fraction. Minus 3 becomes minus 6 over 2, plus 1 over 2 is minus 5 over 2. Okay, that's fractions. Last one. First times first, n times n squared is n cubed. Outer, n times 3 is 3n. Inner, 2 times n squared is 2n squared. Last, 2 times 3 is 6. Now, I say here combine like terms. We don't have any like terms to combine. However, what I want you to notice is this is not written in standard form, it's out of order. We need to rewrite in standard form. N cubed plus 2n squared plus 3n plus 6. The exponents must be in decreasing value from left to right. That's it. Let me see. There's a real world example that I want to take a peek at if I value it. Oh, multiplying a binomial and a trinomial.
It's falling.
Let me think how I want you to do this. I see what they're doing. I don't know if I want to do it that way. That's fine. I would do, they're doing it the vertical method. I would do it the horizontal method. The vertical method, you can see how it looks like. You put the 2 down. Just think of it as if you were doing 5 times 10. Actually, let's think of it as if you were doing 25 times 132. Okay? It's the same concept, just using polynomials instead of numbers. You would go 5 times 2 is 10, carry the 1, that's 16, carry the 1, that's 6. 2 times 2 is 4, 2 times 3 is 6, 2 times 1 is 2, and then you just add them together, okay, to get 3,300. Same thing here. You've got your bigger polynomial up top, your smaller one down below. You multiply across just like your old math way of doing things. Plus 5 times negative 2 is negative 10. Plus 5 times negative 3x is negative 15x. Plus 5 times x squared is 5x squared. Then we shift over 1 just like we did here. X times negative 2 is negative 2x. X times negative 3x is negative 3x squared. And x times x squared is over here by itself as x cubed. And then just horizontally add. Okay, and that's how you arrive at this answer. I would just do this, the way I would probably do this is the horizontal method. And just multiply this term by all 3 and this term by all 3, and then combine like terms. So x times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 2 is negative 2x. 5 times x squared is plus 5x squared. 5 times negative 3x is negative 15x. And 5 times negative 2 is negative 10. And so let's just combine the like terms now. X cubed is by itself. Negative 3x squared plus 5x squared is plus 2x squared. Negative 2x minus 15x is minus 17x. And minus 10 is by itself. So as you can see, I've arrived at the same answer. So whichever way you go is fine. If you want to do the vertical, or the horizontal. Okay? Either way, this is what I prefer, but that's just me. If you like it this way better, you can, if this makes more sense to you, do it that way by all means. Okay? So that is multiplying a binomial times a trinomial, which does happen from time to time. Let me look at this. We're almost done. Yeah, I'm not going to worry about that one. so that kind of sums up our time together. We've done adding binomials, adding polynomials, subtracting polynomials, and then multiplying via the box method or the FOIL method. Whichever way you want to go is fine. So you're going to have homework on both those pages, okay? Homework on whatever the page number is on the other side for adding and subtracting, and then homework here for multiplying. All right, guys, good luck.
Yay.